All right, so as I stated, this whole entire chapter is on conic sections. So as you look at what I just passed out to you, your different types of conic sections that you will be learning are would be the circle, which is super easy, the ellipse, the parabola, and the hyperbola. The ellipse, parabola, and hyperbola are three sets of formulas. The circle formulas are easy compared to the rest of them. And it's not that the formulas are hard, but you need to learn them. You've got one whole week to learn the parabola formula. You've got to study the process. I positively, absolutely am not giving you any of the formulas on your test. You want to know why? Why? Because when I took pre-calc in college, I whined and cried about it, and I fought, and I dug in my heels. And because I did not get the formulas either. You are taking a college-level course, my darling. This is technically a college-level course. And so therefore, the universities expect that you know these. So you need to learn them. So you'll be okay on your quizzes, right? But if I were you, I would definitely learn the parabola formulas this week. And they're not that hard. And as I talk, I will tell you how I remember how to do things. If you can train your brain to derive them so you don't have to memorize everything, it's a whole lot easier. So, enough about that. So let's go ahead and look at parabolas only today. So parabolas are essentially a set of points that are equal distance from, that's supposed to be from, not form, from what's called the focus and the directrix. So I don't know if your Algebra 3-4 teachers talked about the focus and the directrix, but if you did conic sections in 3-4, you at least did parabolas. You may or may not have done the ellipses and the hyperbolas. It depends on who your teacher was. All right, so typically a parabola, and let's go ahead and look at one that opens up. Now the parabolas, for our purposes, they can open up or down, or right or left. This right here is your axis of symmetry. Whatever axis it goes through, x or y axis, that's the equation of, that's how you determine what its equation is. So this particular axis of symmetry goes through the x-axis. So its equation would be x equals, and I'll go through all that in a minute, but I'm just going to put axis here for now. And then you're going to have something called the focus. So the focus is on the axis of symmetry, and it is inside the parabola. In other words, think of the parabola as hugging the focus. It's hugging around that focus. The focus would not be out here because it's not getting a real nice hug from that parabola. So this is your focus. And then you have something called the directrix. So if this focus is that certain distance from, well, let's call this the vertex then, because that'll be important. So that's your vertex. Your directrix is perpendicular to your axis of symmetry, and your directrix is the same distance from the vertex as the focus is. So if the focus is, let's say, whatever that distance is, it looks to be about 1 or 2, then your directrix would be exactly that same distance. It's a dotted line like the axis of symmetry because technically it is not part of the graph. But the directrix can help you find the focus, and the focus can help you find the directrix. And both that focus and directrix are the same distance from the vertex. So you might want to put on here that P equals the distance the focus is from the vertex or the distance the directrix is from the vertex. So they're equal distances away from the vertex, and that distance is called P. We're not going to get through all of these notes today, so day one, we'll get through everything but the last page. So before I get to some specific problems, let's talk about the two formulas themselves. You need to learn these two formulas. So here's formula 1 and formula 2. Can you tell me the difference between the two formulas? This is called standard form, by the way. It's definitely different than what you learned in Algebra 1-2. I like this form a whole lot better. It makes a whole lot more sense. You can see the vertex from the standard form, whereas when you learned how to graph parabolas in Algebra 1-2, you had to calculate the vertex using the opposite of b over 2a as the x value. Remember that? Well, here all you have to do is put the equation into standard form and you can see the vertex right from the standard form. So you've got x minus h squared, but this one's y minus k squared. Do you remember from your circle formulas that whatever's being subtracted from x, h is the x value of the center of the circle, and that whatever was being subtracted from y, which they call k, is the y value of the center of the circle? Do you remember that from the standard form of a circle? X minus h squared plus y minus k squared equals r squared, way back when. Okay, this uses kind of that same thought processes. So a couple things we're going to put on here. Your vertex is going to be hk. Notice that I didn't write negative h or negative k. So if I have x minus 2 here, that means that h has a value of 2. It's whatever the opposite sign is in here. If I had x plus 2, then h would be a negative 2. So whatever the opposite sign is here, that's what happens to your vertex. So you can find your vertex by looking at that. Then it'd be handy to know if this opens up or down. So I'm going to go ahead and put one parabola here, opening up, and another parabola here, opening down. I know that this is a graph of a parabola opening up or down because the x is being squared. If the x is being squared, take your hands and put them alongside either side of the x-axis. Aren't your hands going up and down vertically? Whereas if my y is squared, put your hands on either side of the y-axis, and aren't my hands going right or left? So that's how you can tell whether it opens up, down, right, left. Does that make sense? So over here, you might want to put this is right or left, and this is up or down. Now you used to know in algebra that if A was positive, it would open up, and if A was negative, it would open down. Do you see A in here at all? No. What you see is P. So if P, this value right here, if P is greater than 0, it's going to open up. Why up? Because aren't positive numbers up? Because since this is going up or down, positive numbers are up, negative numbers are down. So for this one, this would represent P being less than 0. I'll make it bigger for you. Then the other thing that I can tell is I can tell what P is. And we'll go through a very specific thing, but you're going to have to be able to find P, because remember, P is that distance that the vertex is from the focus and the directrix. So if this opens up, wouldn't my focus be right here? Inside would be my focus. And would my directrix be outside here, same distance away? So my directrix would go this way. And my focus is inside, so this would be my axis of symmetry. And then my vertex would be right here. So there's my vertex. So how would you find your directrix? And as we go through some of these, I will kind of explain graphically how it might be easier to find it. So your directrix can be found. So if you look on here, isn't your directrix going through what axis? Which axis is it going through? The y-axis. So the equation for your directrix is y equals. But aren't I traveling in the direction of the x-axis? Yes or no? Okay, so since I'm traveling the direction of the x-axis, well, okay, I'm not going to put that way. Go ahead and write this down, and then as we go through some problems, I'll show you an easier way to find this. So your equation for your directrix is k minus p. K relates to y, doesn't it? And for your directrix, it goes through that y-axis at k, but it's adjusted kind of up or down depending upon the distance that p is. We'll talk about how to find that when we have some real numbers. The focus. How do you find your focus? Your focus is an ordered pair. The directrix is actually a line, but your focus is an ordered pair. So the ordered pair must have an x value and a y value. So wouldn't your x value be what h is? If I travel to the left, wouldn't that be the same x value as my vertex? So for my focus, h is my x value. How would I find my y value of the focus? Compare it to the vertex. If the vertex is hk, there's hk, how do I get up to f, my focus? What's that distance there? What is it? Plus p. So if I took k and I added p to it, I'm going to get to that ordered pair. Because remember, p is that distance from the vertex to that focus. And I can kind of do the same thing for the directrix. The directrix, because normally it's y equals k, but it's adjusted for p, because I'm going in the opposite direction, we're going to subtract p, and that's going to get us down, because here's k, right, for the vertex, and I'm going to take away that distance of p to get to the actual real y value. Remember that k is where the vertex is. So if you can kind of remember how you find those, you don't have to necessarily memorize it, but it kind of makes sense. The directrix goes to the y-axis, y equals, and then we visually look at that vertex, and you can tell whether you're going to go up, adding, or down, subtracting. If you need to sketch your parabola so you can remember those formulas, then that's what you need to do. Then look at the other one. So this one, we've got our vertex here. So there's your vertex. And then my focus would be here, right? My axis of symmetry would go this direction. My directrix would go the same distance away, like right here. I would still find the vertex, the directrix, and the focus all the same way. It should not matter. All right, so then look at what happens when y is squared. So this time, if y is squared, remember I'm putting my hands on this direction, right, which means my parabola is opening right and left. So let's put one here and one here. So this would be my vertex. Here would be my focus, because it's inside being hugged by the parabola. And then my directrix would be the same distance, but here. So this is my directrix. And this would be my axis of symmetry. So how does that change our formulas? So my vertex is still hk. That hasn't changed, so that's 1. But then, to get my directrix, what axis is the directrix going through? What axis is that directrix going through? The x-axis. So isn't it x equals? Right? And think about it. If this is a vertex, what ordered pair is it exactly the same on the vertex? Which one's the same? For the directrix, the vertex, and the focus, they all have the same what value? Y value, right? So I know that k, which is my y value, that's going to remain the same. Oops, wait, this one's not an ordered pair, is it? I don't want to write it that way. All right, so how do I tell what x value this is going to be? It originally was here, right? So my x value is really h, isn't it? So for my directrix, what's going to happen? What's this distance? P. Well, on this one, we would end up subtracting p, wouldn't we? Sometimes you might end up adding p. Sometimes p is positive and negative, by the way. So what I want you to put here is just h. Go ahead and do h minus p. Because if p is positive, well, what is p here? Is that positive or negative? If it opens to the right. Positive numbers are to the right, right? So this is when p is greater than 0. And so this would be when p is less than 0 because it's opening to the left. And then the other one that you need to know is your focus. That's your ordered pair, right? So look at your focus. Its value is the same as what on the vertex? X or Y? The vertex. What value is this the same as? Their Y's are the same, aren't they? So the focus and the vertex both have the same Y, which in our case is K, isn't it? So then, similar to this one, but if we're going to the right, wouldn't we be adding P? So the X value of the vertex is H, but we're going to add P to that, because we're going to the right. Left, we would subtract a P. Pardon? Which is why we have the minus Q back. But you're not going to have to memorize that per se. When you physically look at your graph, the very first thing I'm going to try to do is always plot my vertex and figure out, is my graph opening up, down, right, or left? And that's going to tell me, is my focus to the right or the left? When I move to the right, I would be adding. Left, I would be subtracting. Up, we added for the focus, right? And then down with our directrix, didn't we subtract? On this one, correct? Yes or no? Now the same thing occurs, but on this one, and I focus purely on the positive p's. Well, you couldn't see that one. Because on the negative ones, p would be negative, and wouldn't you be subtracting a negative? So when you actually go up with the directrix, you're subtracting a negative, which means you're actually adding. Does that make sense? So when you see the problems, it's going to make sense when you have real numbers. So let's go ahead and look at them with real numbers. So let's go look at number 1. What do you notice first? Y equals 2x squared. Is it in standard form? No. So the very first thing you do is rewrite in standard form. Here on after, it will be noted that that's SF, standard form. So standard form means that the squared term is on the left and everything else is on the right. So the very first thing that I'm going to do is take my 2x squared, and I'm writing on the left, and my y I'm going to write on the right. So I'm going to use the symmetric property, flip them, right? And then I don't want the 2 in front here, so I'm going to divide both sides by 2, and I end up with x squared is equal to, and I need to take y out of the fraction. If I take y out of the fraction, don't I have x squared equals 1/2 y? Now I need to think about this in terms of standard form. So I'm going to write it, if this is x squared, am I going up, down, right, or left? Here's my x-axis, right? I have to be going up and down, right? Up and down. So I would write myself a note that this is up, down. I don't know which it is yet. I have to find p to find that out. And 1/2 is not p. So to put it into standard form, according to the formula up there, I've got x minus something squared equals 1/2 times y minus something squared. Can't I factor the 1/2 away from the y? Right? What's being subtracted from x to make it x squared? What number should really be here? If nothing is here, what number's here? Nothing. What number's nothing? Would you agree that x minus 0 squared is still going to give me x squared? True or false? Yep. Same thing over here, wouldn't you agree that that's y minus 0 squared? And if I did y minus 0, that'd be y. Oh, I don't need squared. Whoopsie poopsies. That's a way, right? I can't have both of them squared. If they're both squared, what is it? Yeah, it's a circle. Oops. All right, so then from there, I want to find my vertex, my focus, my directrix. I might ask you for the axis of symmetry. In my classroom, I always want you to put that in there. So you should always have two perpendicular lines. So I may ask for the exact equation or not, but neither here nor there, it's always on your graph. So step 2, I guess, technically, we're going to find our vertex. So what is your vertex? Yeah, you can see it right here, isn't it 0, 0? So immediately, I'm going to plot that vertex right here and label it B. I still don't know whether it opens up or down. So that's next is I'm going to find P. So step 3, find P. Now, isn't this part right here, isn't this part equal to 4P according to the formula? This part right here? Shouldn't that be 4P? The formula says right up here that that's 4P. Do you see where I'm getting that from? Yes or no? Okay. So then I'm going to take, if 4P equals 1/2, can't I set up that equation? And solve for P. So I'm going to divide by 4. Dividing by 4 is the same as what? Multiplying by 1/4. So doesn't P equal positive 1/8? Since P is positive, what do we know about our parabola? Opens up, right? So the minute I know it opens up, I know that my focus is above the vertex, and I know my directrix is below the vertex. Because P is 1/8, I know that my focus is literally 1/8 away from the vertex. I don't have to know the math behind it because I'm graphing it and I can see it. Can't I then tell you what the ordered pair of the focus is without memorizing all those stupid formulas? You know, one for the directrix, one for the focus, one when it's up or down or right or left. Take the confusion out and use your logic. So then step 4, I want you to find the actual ordered pair of the focus. For your note purposes, I'm going to have you put on here that it really is H and then K plus P. I don't normally memorize that. I'll usually just kind of figure it out. But isn't my X value, the focus, going to be 0? What's my Y value going to be? What's this? How far, remember this distance is P, how far is that from the Y value of the vertex? If Y is 0, how far up do we have to go? 1/8. So isn't my focus 0, 1/8? So I'm going to label this as F. If you don't have enough room like we don't on this one to put the ordered pair in there, then you just have to have it off to the side and label it as focus. Then the last part that we really need is 5, your directrix. And my directrix is going to go in this direction, right? And isn't my directrix 1/8 below this? And I do want to label that. What axis is it going through? The y-axis. Y equals, where on the y-axis is it going through? If this was 0, 0, how far down did we go? 1/8, and it's a negative 1/8. So doesn't that mean that my directrix, and for your note purposes, you can put here that the directrix was y equals k minus p. So that means that our equation is y equals negative 1/8. Whoops, don't know where the 1/2 came from. So there's those pieces. Then the only other thing I need you to put in here is your axis of symmetry, which is right going down through the focus and the vertex. It's also a dotted line. What's the equation of this? What axis is it going through? What axis? X at what value? 0. So isn't that x equals 0? Then all you have to do is sketch the parabola. I'm not making you make it really wide or really narrow right now. These are the only parts that I'm super interested in. So I just expect you to sketch it. If you want to get exact values, fine, whatever. We've done that before, haven't we? I'm more interested that you're sketching the focus, the vertex, the directrix, the axis of symmetry, And then if I needed to do a narrow versus a shallow parabola, we can do that later. You can plug in ordered pairs, whatever you need to do. All right, so let's look at the back. That wasn't so bad, was it? You have to know the main formula. You can get around knowing how to find your directrix and your focus if you're graphing. I don't ever memorize those. All right, so here we go. All right, so number one, are we in standard form? All right, so standard form. Take your squared term, which is this one right here, and you want it on the left. So I'm going to keep the y minus 2 squared on the left. How do I move x plus 3? Huh? You subtract it. It's a big thing to subtract, but we subtract it. So don't I end up with a negative x plus 3 on the right? Technically, what's in front of those parentheses? A negative 1, right? Doesn't this right here represent 4p? That thing that's in front of the parentheses is 4p, right? Then, because the y is being squared, put your hands around the y-axis. I'm going what? Up, down, right, or left? Right and left. I don't know which yet, but I know that this is right or left. So I kind of have an idea. So the very first thing we're going to find is the vertex. So step 2, vertex. What's the x value vertex? Careful, these are backwards, right? Look at your x parentheses. What's the x value? Negative 3, because you want the opposite sign, right? And then what's the y value? Positive 2. So I'm immediately going to plot that point on my grid, negative 3, positive 2. So there's my vertex. Then next, I need to find P, because I have to know whether it opens right or left to figure out where the focus is. And P is going to help tell me that. So find P. What is your formula for finding P? (4p) is equal to negative 1, isn't it? So 4p is equal to negative 1. What does p equal? Negative 1/4. So this is where I don't remember formulas, right? So we have to find the formula for the focus. So the focus, okay, if p is negative, am I going to open right or left? So this opens left because left is negative. So I know that my parabola is going to go in this direction, right? So is my focus to the right of the vertex or to the left of the vertex? To the left. So I know my focus is over here. And isn't my focus 1/4 to the left? True or false? Just 1/4, a distance of 1/4. So I'm going to put a little dot there and put my focus here. Now, the x value of that vertex is what? Negative 3. So what's negative 3 plus, I'm going to say a negative 4th because I went to the left, right? If I just add a positive 1/4, won't that move me to the right? You see what I'm doing? So what's negative 3 plus negative 1/4? If I were you, I would write it as negative 3 1/4. You don't have to make it into an improper fraction. We are graphing after all. How far up did you go for the focus? The same as the y value of the vertex, right? Then we go up 2. So isn't the focus negative 3 1/4 2? How are you going to find the directrix? So the directrix is going to be going this direction, right? Because the directrix does not contain either the focus or the vertex. It does not contain those. That's the axis of symmetry. So that's your directrix. What axis is it going through? X. So I know that it's x equals use your vertex to figure out what value of x this is. This value of x right here is -3. So if we went, because p is 1/4, don't worry about that's negative. P is 1/4 away from the vertex, we're going 1/4 this direction. So what number would that be? What's 1/4 to the right of -3? -2 and 3/4, right? And again, you can write that as a mixed number. That's fine. And I'm going to label that on here, x equals -2 and 3/4. Then you still have your axis of symmetry, which does contain the focus and the vertex. What axis is this going through? X or y? Y. So it's y equals what? What value is this? 2. Now, can't you just draw, sketch in your parabola? And again, I really don't care how shallow or narrow you make it for right now. I'm more interested, can you find the focus, vertex, directrix? Was that easier? How much are you having to memorize on formulas? Because you're relying heavily upon your knowledge of graphing, right? I would if I were you. All right, look at number 3. What's wrong with this one? Yikes. There's no parentheses, right? What do you think that means to you? You're going to have to complete the square to create parentheses. Yay. So here's what I want you to do. Write yourself a note. Do you see that x is squared? So we're going to take anything that's squared, and that includes any variables that would relate to that. Wouldn't the x relate to the x squared? Okay. So we're going to take those and keep them on the left. So your note to yourself is, put the squared variables on the left, and everything else on the right. If the y were squared, you take the y squared and the y term, and that would be on the left, and you move everything else to the right. You're not going to have 2 squared terms. If you have 2 squared terms, then we're no longer talking a parabola. We're talking an ellipse, a hyperbola, or a circle, because those actually have all squares. So, for step 1, standard form, I'm going to start off with x squared minus 2x, please put a plus blank because we are completing the square, equals. When I subtract the 8y, it'll be minus 8y, and I'm going to subtract the 9, so it's minus 9, and then plus another blank, because whatever I put on the left side, I must put on the right side to complete that square. Do you remember how to complete the square? Take b, which is the coefficient of the non-squared term, in this case the x term, divide it by 2 and square it. So that's really what c is. C is your constant. So we're going to take, and you can worry about sign or not, it's going to come out positive no matter how you do it. I tend to ignore the signs. So I'm going to put in this 2 right here in here. So 2 divided by 2 is 1, squared is 1. So to complete the square, I'm adding a 1 here and a 1 there. When you complete the square, 100% of the time, what you add to both sides is positive. If you're adding a negative on there, you did something wrong. So now, I can rewrite this as, how does this factor now? Right, the whole purpose was to create this perfect square trinomial, which factors into 1 binomial squared, which is what we're trying to get on the left side. Take the square root of your bookends. That's the first and the last term. What's the square root of x squared? X, square root of 1, 1, and what's the sign of the middle term? So a negative goes in there. So if this were a positive, you put a plus there. That's how you know what your signs are. Equals. Then we have over here negative 8y, a negative 9, and a positive 1 is a negative 8. We don't have parentheses on the right side. This does not look right. You've got to factor whatever is in front of the y out, because there shouldn't be a coefficient in front of the y. So we're going to factor, fortunately, a negative 8 factors out of here too. If it didn't, you'd have a fraction. So we end up with x minus 1 squared equals factor the negative 8 out. So you get a positive y. Divide that by negative 8, don't you get a plus 1? Now it's in standard form. And that was the kind of the pain about this one. So that's step 1. Step 2, what should I be looking for right now? The vertex. So what do you think the vertex is, looking at this? Positive 1, negative 1. So I'm going to go ahead and plot that. So I've got to the right 1, down 1. Because my x is squared, I'm going to put my hands around the x-axis. Am I opening up, down, or right, left? Up, down. I don't know which yet, but this is definitely up, down. So now don't I find P? Find P. How do I find P? Yeah, remember this negative 8 here? Isn't that negative 8 in the position where the 4P should be? Whatever number is out in front of the parentheses on the non-squared side, that's supposed to have a value equal to 4P. So 4P is equal to negative 8. What does P equal? Negative 2. Because P is negative, does this open up or down? Opens down. Now P is huge, meaning it's important, not big. But I know where my vertex is, and if I know P, I immediately know where my directrix is and my focus, because I know that it opens down. So since it opens down, it's going to open this direction, right? So isn't my focus down below the vertex? How far down? 2. So count 1, 2. This is your focus. That's a nice happy ordered pair, isn't it? So your focus is what? What ordered pair? 1, 1, 2, 3, negative 3. I didn't have to memorize a formula. Then what else can I find? My directrix. You will nearly always see me drawing the directrix in first because it makes my brain aware of whether it's x equals or y equals. So the directrix is 2 on the other side, so we'd be going through here, right? What axis is that going through? The y-axis, right? So isn't this y equals? Y equals what number? 1. 1. What's the last thing you have to have? Axis of symmetry is the last thing you'll see me putting in, mostly so that I don't confuse it with the directrix. And so what axis is that going through? It's always going through the other axis, right? So if the directrix is y equals, the axis of symmetry is x equals, and what number? 1. Then you need to sketch in your parabola. And this would be your vertex. That was easier, right? Except for the standard form part. All right, look at example 4. Any questions before we move on? Are you feeling less anxious? Yes?
Is the directrix not a point?
No, it's a line. Directrix is always a line. Focus is your point.
Because for our last one, you wrote it as an ordered pair.
No, I didn't. Did I? No, I didn't. You're making me nervous there. The first one I almost did, but I caught myself. Because in my brain they're one and the same, but one is a line and one's an ordered pair. So I rely heavily on the graphing. That way I don't have to memorize so much. Because you've got, if you try to memorize all those formulas that I gave you earlier, I mean, some of you like to memorize, like Caitlin, you're really good at memorizing. You probably would prefer to memorize the formulas, right? Because that's what she's good at. I don't like to memorize, so I'm going to rely heavily on the graphing. All right, so then example 4, you're not given the formula, but you have to write the formula. So we're going to plot, use our graphing to help us with it. So we know our vertex is -1, +2. And isn't this h and k? When they give me my vertex, I immediately know h and k. And then the focus, I'm going to plot that, because when I plot that, I'm going to know how far the focus is from the vertex, and won't that give me P? If I know H and K and P, and whether it opens up or down, because that'll tell me whether P is positive or negative, or right or left, depending upon what I have. Plotting that focus is going to tell me if I'm up, down, right, or left. So my focus is at -1, 0. This is my focus. This is my vertex. If I were to sketch this parabola, wouldn't it sketch this way? Because the parabola hugs around that focus. So this is one that opens down. So if it opens down, are we scoring the X or the Y? Opens down, up, down. I have my hands around the X. So I know that I'm going to have it in the form of X minus H squared equals 4P times Y minus K. Now that I do expect that you will have that memorized. That's not so hard to memorize, right? Now plug in the things that you know. X minus 4 times, we'll find those in a minute, and then Y minus. So let's find how far apart these are. How far apart are these? Because this is P. What's that distance? 2. Is the parabola opening up or down? Down. So is this a positive 2 or a negative 2P? It's a negative, right? So that means that I'm putting a negative 2 in here for my P. If it had opened up, I would have just had a positive 2. So that kind of tells you have to know the sign of your P. Kelsey, you're okay? Are you overwhelmed or just tired? Okay, don't give up on me. We're almost done. All right, so then notice that I'm not asking you to put in the directrix or anything like that. You could. I'm not asking you to graph it. I'm just asking you to write it in standard form. So the graph is there to help you find what you need to find. Can't I just go ahead and put in H and K? So H goes with my X, so it's a -1, and K goes with my Y, so it's a 2. Now I have to simplify where I can. The minus minuses become a plus, so I get X plus 1 squared equals 4 times -2 is -8 times, and the Y minus 2 stays the same. Isn't this my standard form? Right? Now if you felt incomplete, you wanted to put in your directrix and your axis of symmetry, feel free, go right ahead. You could. Wouldn't your directrix be 2 away from this direction right here? Right? And it goes to the y-axis, so it's y equals, and it's at 4. Your axis of symmetry is going this way. It's going through the x-axis at -1. So I feel so much better now. Last one. This time they give you the vertex and the directrix. Anytime they give you the focus or the directrix with the vertex, you automatically can find P just by graphing it. I could make you use the formulas, but why? All right, so let's go ahead and focus here. I've got an H and a K from my vertex, so I already know that. I'm going to plot that vertex, which is -2, +1. My directrix is x equals 1. That is the graph of a line. X equals means you're going to put a point on the x-axis at +1. So here's the x-axis at +1. How do you cut that axis into 2 pieces? With a vertical line or a horizontal line? It has to be vertical. So I know it goes this direction, and this is x equals 1. That means that the distance from here to here represents P, doesn't it? My focus would be on the other side over here, by the way, because vertex is always in the middle of the directrix and the focus. So I know the focus is to the left. How far apart are these? How far apart? 3. If my focus is also 3 to the left, 1, 2, 3, this is my focus, that means that my parabola is going to open this way, doesn't it? So is my P positive or negative? That makes it negative. That's all I need to write my equation. So here's my general equation. I'm going to write it down here because I don't have a whole lot of room. So because I'm opening right or left, you want to put your hands this way, right? I'm opening right or left. What axis am I covering or holding my hands around? The y-axis. So doesn't that mean that your y is being squared? So that means that your formula is y minus k squared equals 4p times x minus h, because h always goes with x, k always goes with y. So plug in the things that you know. You know your k. You're going to know your P, and you're going to know your H. My K is 1, my H is -2, and my P we found was -3. There's no need to pack up. We have 4 more minutes. So we have y minus 1 squared is equal to 4 times 3 is -12. These negatives become a positive, so I have x plus 2. There's my standard form. And if you felt incomplete, put your axis of symmetry this way. It's going through the y-axis at +1. That's not so bad, is it?